All right, welcome to Unit 2, Lesson 6, Part 2 video. We left off with our radicals and multiplying and dividing them. All right, it's going to be a little bit to get through. I'm going to go through it kind of at a quicker pace just to finish it off and not make this video like 40 minutes. So let's just get started. First, I would like to go over a few rules of thumbs, so to speak. If I have two things under a radical, and the root is the same, like these are both square roots or cube roots, and I multiply them, I can multiply them together and put them under one root. Okay, that's fine. This actually goes both ways. Okay, if I have two together, I can make them separate, each under square root. Or if I have two under square root, I can put them together under one square root. Okay, so your rules for multiplying, you can almost multiply just like there aren't the radical sign there. And then just make sure you carry the radical sign over. Meaning, if I have A times B, that's AB. Okay? If I have a radical sign over both of these, then I just put a radical sign over this. Division works the same way. If I have A divided by B, okay, and they're both under radicals, that's like saying A divided by B. I can divide both of these out, okay? Meaning, and I'll use numbers for the division part. If I have 2 divided by 8, all right, that's really 1/4. So if I had radical 2 divided by radical 8, that's like radical 1 divided by radical 4. I could put it under one radical if I wanted to. It doesn't matter, okay? But I can divide just like, okay, and I'm going to stress this again, I can divide just like there are no radicals there. Okay, that equals 1/4. So if it was like this, it would be like that. The square root of 1 is 1. The square root of 4 is 2. Okay, so I can multiply and divide with radicals just like I would if the radicals weren't there. But please make sure, if there is a radical there, when you divide, you still need to keep your radicals. All right, same thing with multiplication. All right, same thing with multiplication. So let's do this. Let's get rid of this poo-poo, and let's get started. We'll start with blue. I'm going to multiply these together. 7 times -5. Okay, that's going to give me -35. Right? Now I have 24 times 5. That's the square root of 120. Again, 24 times 5 is 120. But if these have square roots, this needs a square root. Okay? That's all I did. Now, the biggest perfect square that goes into 120 is 4. All right? So this is off a little bit, but that's fine. So that's like saying the square root of 4 times the square root of 30. And the square root of 4 is 2. So I'm pretty much done simplifying everything I can. 35 times 2, well, it's -70. And that's the only thing that's still under the square root sign. Okay? Good, good. It's good, it's good, it's good. Let's take a look at number 2. All right, these are both under cubed root signs. So I can multiply everything together as long as I keep the cubed root. So 4 times 10 is 40. All right? X times x to the 5th, that's x to the 6th, okay? Don't forget, when I multiply variables, I add the exponents, okay? So if these were under cubed roots, my product should also be under a cubed root. And this goes back to what we were doing before, simplifying radicals, okay? I say the cubed root of 40, separate from the cubed root of x to the 6th. Some of you are really good. You might not even have to write cube root of x to the 6th. Because don't forget, I just divide. 6 divided by 3 is 2 with a remainder of 0. 2 x's come out, and none remain under the radical. That is simplified. All right, so now we're looking at the cube root of 40. I don't want square roots. I want cube roots. So I want a perfect cube. The biggest perfect cube that goes into 40 is 8 times 5, okay? Cube root of 8 times cube root of 5, and the cube root of 8 is 2. I have simplified everything I can right here. I have, yep, that's my blue marker. I have 2 cubed root of 5 x squared. So everything outside the radical, 2x squared, stays outside. What's left for inside? Just my 5. And you're done. Bam. Saucy. All right, let's go on to number 3 and number 4. If you want to, and I've said this before in all my videos, if you want to pause this, do these yourself, and then watch me do them to see if you got them right. As soon as you start feeling comfortable with them, that's what you should do. Because if you do them right, that's great. But even if you do them wrong, you should see where you did them wrong. And that's where you know you need kind of the reminder or that slight help or that one thing that you can't forget that you always do forget. Okay, if you're just copying, blindly copying, okay, you're taking notes, but you're not really, testing yourself to see if you can do this on your own. And there is a Regents exam at the end of this course. And unfortunately, you're not going to be able to watch me do the exam in front of you on the board and just copy. You're going to have to do it on your own. All right? So here we go with 3 and 4. I'm going to multiply negative 16 times negative 4. Woo! That would give me a positive 64. Okay? I'm going to multiply 20 times 5. Okay? And that is 100. But since these are under square roots, my 100 needs to be under square roots. Oh, this is perfect. The square root of 100 is 10. So we really have 64 times 10, which is 640. This is a great example of why we need to multiply radicals. I cannot take the square root of 5. Okay? I can't do it. Okay? It's not going to give me a whole number. 20 is not a perfect square either. But when I multiply them together, I get a perfect square. Okay? Beautiful. That's a great problem. Number 4. I'm going to handle these like they are slightly different. And when I say different in these, I mean the numbers that are under the radical versus the numbers that are not. And I'm going to kind of view these as 2 separate fractions. First, I'm going to see if I can simplify negative 20 over 6. Yeah, 2 goes into both of those. This fraction right here with just these numbers actually reduces to negative 10 over 3. All right? Now I'm going to take a look at my radicals. Remember what Visca said. I can divide 2 radicals, all right, just like the radicals weren't even there. So if I took 200 y cubed and divided it by 40y, 40 goes into 200 5 times. 1y here cancels with 1y here. So when everything's all said and done, I have nothing left in the bottom. I have a 5y on the top. So I put 5. Oh, excuse me, that's y squared. Ooh. Okay, I had 1 here. I took 1 away from 3 and got 2. Okay. But since I had radicals here, I need to keep my radical here. Right? I can't do anything with my negative 10 and my 3. Okay? So when I think of the square root of 5y squared, I can't do anything with the square root of 5, but I can do something with the square root of y squared. That ends up being y. Squares and square roots cancel, don't they? Or if you want to think of it, this is a 2 and 2. 2 divided by 2 is 1 with a remainder of 0. 1 comes out, 0 remain in. Okay? So I have negative 10 times the square root of 5 times y all over 3. And I like to put my square roots last. Okay? So I'm going to move that y up front. So I'm going to say negative 10y radical 5 over 3. That's your answer. All right, 9 through 14 are going to be practice numbers, although I have 5 through 14 here. Interesting. So I'm just going to start to rip through some of these. I would like you to try these on your own. And I'm just going to rip through some of these so that you get answers, okay? All right. 12 divided by 4. Negative 4 is negative 3. If I divide these two, that is the cubed root of 16. And this is the cubed root of 8 times the cubed root of 2, and the cubed root of 8 is 2. So negative 3 times 2 times the cubed root of 2. I get negative 6 times the cubed root of 2. Bam. All right. This one right here, number 6, 72 times 10, that's 720. X cubed times x, that's x to the 4th. This gives me y to the 5th, and that's all under square root. Okay, 144 times 5, I think that is. Let me check this out. 144 times 5, that's 20, carry the 2. Yeah, perfect. Base perfect square that goes into 720 is 144. So, square root of 144 times the square root of 5. Okay, if I divide these out, I get 2 x's, and I get 2 y's with a remainder of 1 y. Okay, this ends up being 12. So what is outside? 12 x squared y squared. Okay, and what is still under my radical? 5y. Oh my goodness gracious. There you go. Please note that if you're foiling these, 2 minus radical 3, don't just square both of them. You're actually multiplying it by itself. All right. You know what? We've done this before. So 7, I'm not going to show you the answer for. I'll probably assign that for homework, as I maybe did 5 and 6. But 7, 8, 9, 10, these are all foiling. Okay, you should be good at these. So I'm going to let you guys do those on your own. All right, and move on to the next one. Okay, rationalizing the denominator. Right? If they ask you to simplify a fraction, okay, I cannot have a radical in the denominator or in the bottom. So if it does have a not rational value, a radical, okay, I need to make sure it does not have a radical in the bottom of my fraction. All right? And they really are, if you know your perfect squares and your perfect cubes, you're good to go. Okay? So, let's take a look at number 1. All right, I have radical 8 on the bottom. I have 5 over radical 8. And this goes back to the old faithful rule with fractions. If I have a fraction, okay, and I multiply the bottom times something, it would not keep its value. The only way it would keep its value is if I multiply the top by the same thing I multiply the bottom by. Now, these are both 0.5 or a half. Okay? They both represent a half. So what I do to the bottom of a fraction, I have to do to the top. Okay? And vice versa. If I do something to the top, I got to do it to the bottom when it comes to multiplication. If I want the fraction to maintain its value. All right? So I notice I have a square root in the denominator. What can I multiply 8 by so that it becomes a perfect square? A lot of people say 8 times 8. Visca, I just want to multiply the bottom by itself. But that might create a lot of reducing later down the line, okay? I will show you that example after I show you the way I do it. All right, so I will show you the second way. But first, there is another perfect square that I can turn 8 into that is smaller than 64, and it is 16. Okay, 16 is a perfect square. So if I multiply 8 times radical 2, I get a radical 16 on the bottom, which is 4. What I do to the bottom, I have to do to the top, okay? And we're done. That's it. Now, that's the way I would do this. Now, some people, like, either they struggle with memorizing perfect squares, which is crazy because it's really just multiplication. And at this level, you should know multiplication. All right? But some people want, you know, something that works, that's mindless, that they could just start working with it. And I get that, okay? So what I'm going to do here in red is a secondary way. If I have 5 over radical 8, some people say, well, radical 8 times radical 8 is the square root of 64, which is 8. If I multiply two things together that are under a radical, radical 11 times radical 11, the answer is just the number without the radical. How come? Because it's the square root of 121, which is 11. Okay, that works every time. So people say, oh, I can get rid of the radical here. Okay, I can get rid of this radical here by multiplying it by itself because it just becomes that number. And it does. Okay, and you'll still get the right answer if you do it this way. And on top now, you have 5 radical 8. But here's what you got to remember. That's not what the simplest form was. If they want it in simplest form, that means, yes, get the radical out. But if you can simplify it any further, you have to. Okay? Let me state that one more time. If they tell you to simplify, or they want something in simplified form, not only do you have to take the radical out of the bottom, but if you can reduce anything else in that fraction, obviously, if I have 4 over 8 and I want it simplified, I don't say, yeah, there's no radical. That reduces to 1/2. So if I can reduce a fraction, I need to if they tell me to simplify. So not only do I take the radical out of the bottom, but I need to reduce it if I can. Obviously, my answer in red here doesn't match my answer that I have in green. That's because the square root of 8 can be broken down. 5, the square root of 8 is like 4 times 2, right? And the square root of 4 is 2. So 5 times 2 is 10, radical 2 over 8. It's still not reduced because now 2 can go into 8 4 times, it reduces, and 2 goes into 10 5 times. So when I'm said and done, I can get the same answer. Okay, I can. But there is a lot more work if reducing is involved afterward. How can I ensure that there's not going to be, or I'm going to reduce as much? Well, that's kind of weird to say reduce as much, reducing. But how can I make sure that I really do as little reducing as possible? Try and get the smallest perfect square instead of, this is radical 64. That's how I get 8. Try and get the smaller perfect square instead of the bigger one. All right. You can do it the way in red. Visca, I'm still good at that because I can reduce. Fine. You're good. As long as you get the right answer, mathematically relevant, you're good. But I tell you what I wrote here in green seems a lot less complicated and easier to do. And everybody's always asking to make math easier. That's how you make math easier. All right, let's take a look at number 2. Now, this is not a square root on the bottom. It is a cubed root. So I want to make 4 into a perfect cube. Excuse me. I just gave you the answer. I want to make 2 into a perfect cube. The first perfect cube that I can make 2 into by multiplying it by something is 8. And I multiply that by 4. Okay? So if I multiply the bottom by the cubed root of 4, I also have to multiply the top by the cubed root of 4. So I've got 7 times the cube root of 4 all over the cubed root of 8. And the cube root of 8 is 2. So my answer is 7 times the cubed root of 4 all over 2. Okay, special note here. I know we said, oh, if things have radicals, we can simplify them like the radicals aren't there. Yeah, if I have a radical on the top and a radical on the bottom, I can divide them. I cannot, however, I cannot reduce my 2 with this, okay? Because one of them is under a radical and one of them is not, okay? They either both need to be under a radical or they both should not be under a radical, okay? Don't start crossing off that 2 and saying, oh, 2 goes into 4 twice. No, stop. Don't. Stop right there. When it comes to multiplying and dividing, radicals with radicals are okay. And things without radicals and things without radicals are okay to reduce and combine, okay? Big rule. Next one, number 5. All right, I'm going to multiply this times the cubed root of 25. Top times the cubed root of 25. How come? Because even though I have 2 times the cubed root of 25 on top now, 5 times 25 is 125. And that is a perfect cube. That is 5. There is no other perfect cube that you can turn 5 into by multiplying it except 125, all right? So when everything's all said and done, 2 cubed root of 25 all over 5. Bam! See, they're not so bad. Wow, what the heck just happened there? That was weird. Weird. Undo. There you go. All right. Number 3. Number 3 is a doozy. What I'm going to do is I'm going to divide this out as best I can without the radicals being there. Know what I mean? So, I have, all right, I'll just rewrite this without radicals. I have 12ab cubed c squared over 10a cubed bc squared. All right, now, if I were to reduce this, like I didn't have radicals, 2 goes into 10 5 times. 2 goes into 12 6 times. All right, that's not bad. Okay, one of these a's cancel with one of these, and I'm left with 2. This 1b cancels one of these, and I'm left with 2. Oh, and this c on the bottom, as nice as it would have been, is a 1. And one of these cancels with one of these. So I have 1 left. So if I rewrite this, I have 6 b squared c on top, okay? 6 b squared c. All over. This is a b, not another 6. 5 a squared. No, that's it. 5 a squared. Now, let's not forget, these originally were under cubed roots, so I'm going to keep them under cubed roots. So what I need to do is, not only do I need to make my 5 into a perfect cube, but I need to make my a into a perfect cube. Okay? Which means I want to make my exponent for my a something like 3. So when I divide it into it, there's no remainder. Okay? I can make it 6. I can make whatever. But doesn't cubed roots cancel with something cubed? So I want to make my a have an exponent of 3. So I'm going to multiply the bottom by 25 a to the first, okay, under a cubed root. So what I do to the bottom, I have to do to the top. I have to. I absolutely have to. All right? So now let's see what happens. Let's see what happens. There we go. Okay. On the top, I'm going to have 150 a b squared c, all under a cubed root. All right? In the bottom, 5 times 25 cubed is 125. Oh, that's a perfect cube. Perfect. A2 times A1 is A3. Perfect. Look what happens here. The cubed root of 125 is 5. The cubed root of A cubed is A. So my bottom is going to end up being, and you really don't have to write that, I mean, if you see it. The bottom is going to end up just being 5A, all over the cubed root of 150 AB squared C. That is good because none of those are perfect cubes up there. All right? So that one that was a little bit more work. That was a gut check. That's what we call a gut check. All right? You've been feeling comfortable. Okay, feeling comfortable? Here's one. Do it. This isn't made up of anything that you don't know. It's made up of multiple things that you do know. Okay, and it's cube root instead of square root. So yes, it's more difficult than the previous problems we've been doing, but it doesn't have anything that you don't know. All right, adding and subtracting radicals. I'm not going to spend too much time on this. I just want to show you the basics. And there's one basic rule. Okay, whenever I add or subtract, I'm not talking multiplying and dividing. Okay, I can take radical 3 times radical 6 and get radical 18. Okay, but I cannot add radical 3 and radical 6 to get radical 9 or radical 18. This is a no-no. Okay, so when it comes to adding and subtracting, which you'll hear us say combining a lot. Okay, now combine like terms, right? When it comes to combining, There's one rule that I tell my class. Radicals are like variables. You only combine like terms. Which means, all right, if I have x squared plus 2x, I can't say this is 1x squared. I can't say that's 3x cubed. No. These I got to leave like that. The minute the variables are the same, they become like terms. So that's 3x squared. Same thing with radicals. I cannot take the square root of, I can say this is 3 square root of 2 plus 4 square root of 3. I can't combine those. These are not the same. They're like variables. Okay? Now, if this became a 2, now I have 6 square roots of 2. Notice the square root of 2 doesn't change. Okay? Notice this does not change. Just like my x squared didn't change, did it? Okay? So if you want, you can think of these kind of like, oh, this is a variable. What happens if I had 3x and 4x? Yeah, you know what? I'll be okay. I would have 7x, not 6x. Okay? I'm thinking my 4 and my 2 instead of my 4 and my 3. Okay? So they need to be the same in order to combine them. This is where knowing how to reduce and simplify just radicals on their own are awesome. Because I'm going to look at this right here. I'm going to look at number 1. This 9 just comes for the ride. Times. Okay, this is square root of 25 times the square root of 2, correct? And 25 is 5 times the square root of 2. I get 45 radical 2. That's just for my first term. Minus, okay? Let's do this another color. Minus, if I can simplify this, okay, my 12 comes for the ride. 98 is radical 49 times radical 2, and 49 is 7. So I have 12 times 7 times radical 2. That gives me, any takers? 84 radical 2. Okay, 84 radical 2. Now, since these radicals are the same, they're both square root of 2. It's not square root of 2 and cubed root of 2. They are both square root of 2. I can combine those terms. If they were not, I would have to leave it just like that. Meaning, okay, now I have 45 minus 84, 29. 29. 29. All right. So I should have negative 29 square root of 2. All right. And by 29, I really mean 39. Okay. So I have negative 39 square root of 2. All right. If this, okay, I'm going to show you what I'm talking about where they have to be the same. This step right here. If I happen to simplify everything above, all right, and I ended up with 45 radical 2 minus 84 radical 3, I cannot combine those. I have to leave it just like that. This would be my answer, okay, because they do not match. If I would have had this, the cubed root of 2, they still don't match, okay? Yes, there's a 2 under the radical sign for both, but one of these is square root and one of those is cubed root. They are different roots. They are not the same. I would have to leave it like that. The only way I could combine these would be if they were the same. All right, let's take a look at another one here. Let's go down here. Let's take a look at number 3. Let's do a cubed root one. Okay, and let's try this thing right here. All right, so my 7 comes along for the ride. 7 comes along for the ride. All right, the cube root of 16, that's the cube root of 8 times the cube root of 2, and the cube root of 8 is 2. So I've got 7 times 2 times the cubed root of 2, which is 14 cubed root of 2. That's my first term. Plus Now I got to simplify this. The 10 comes along for the ride. This, oh my goodness gracious, is that 27 times 3? It is. The cubed root of 27 times the cubed root of 3. And the cubed root of 27 is 3. All right? So I have 10 times 3 times the cubed root of 3. That's 30 times the cubed root of 3. Okay? Do my radicals match? No, they don't. So there's nothing else I can do here. So I'm going to leave my answer just like that. Okay, I'm going to leave my answer just like that. And I'm not going to do the rest because it's just multiplying and it's adding and subtracting. We are done. I will see you for Unit 2, Lesson 7. Okay? And I hope you have a good one. It is Regents Week for us in January next week. So if you're taking January Regents, good luck. If not, hey, good for you. See you later.